Hello, so in this video we are going to talk through this idea of the product moment correlation coefficient. So it's a bit of a mouthful, sometimes called the PMCC for short. It was derived by a guy called Carl Pearson actually, he kind of thought about it first. And so sometimes it's also called Pearson's correlation coefficient, which is slightly easier to say. But effectively this is what we're going to start looking at. Because what we want to try and do now is quantify the correlation between two variables, okay, in a bit better way than just being able to draw a regression line through them, okay? So the product moment correlation coefficient, or the Pearson's correlation coefficient, is usually denoted by the letter R. And we're going to actually sort of think about this in a little bit more detail and think about the ideas which Pearson kind of thought about when he was thinking about this. But essentially, R is a number that varies from -1 through to 1. Okay, so it varies from -1 through to 1. Now, the idea is 0 is in the middle. So if your R value, if your correlation coefficient, all that simply is, it's just a measure of the strength of the correlation and also the type of the correlation as well. So if your R comes back as 0, it just simply means that there is no correlation between your two variables, okay? So there's no visible correlation between your two variables. Now, that's got to be very careful about how you say that, and I'll talk you through that in just a second. But for the moment, let's just say there is no correlation if the R value is 0. Now, effectively, for anything which is positive, so for anything on this side, okay, so for R which is greater than 0, we say that there is a positive correlation. Okay, in other words, as one variable increases, the other variable also increases. And the strength of that correlation, so how closely they match a linear straight line, is given by the value of 0 to 1. Okay, so if it's 1, it means it matches it in a perfect way. Okay, likewise, if you look at R being negative, no surprises there, we're talking about a negative correlation. In other words, as one variable increases, we expect the other variable to decrease. And again, that strength of that correlation is given by the closeness to -1. So if it's -1 exactly, it means it follows a near perfect negative line. Okay? Whereas if it's a value which is closer to 0, it just means a slightly weaker correlation going on. But I think the best way to illustrate this idea is through pictures. Okay, so as long as you understand that R is a value that lies between -1 and 1. If the value is negative, it means that as one variable increases, the other variable decreases. And if the value is positive, it means as one variable increases, the other variable also increases. So let's have a look at positive correlation first. So I've drawn two types of positive correlation here, okay? Now the graph, they're both positive, you're happy because as one variable increases, the other variable also increases, okay? So for example, this could be age and height. We've looked at that example before, okay? So as age increases, we expect the height to also increase. That would be an example of positive correlation, okay? Another way you can think about this is kind of tying it back to regression analysis, is that if we are going to draw a line of best fit or a regression line through these data points, we expect the gradient to be positive, okay? So that's another way of interpreting positive correlation, just try and tie things together. Now the one on the left, we say is weaker correlation, because if you have a look, if I'm going to draw my line of best fit or my regression line through these data points, let me do a bit better, okay? They don't really match the line very well, okay? There's quite a lot of distance, the residuals are quite big, okay? Whereas if you look at the one on the left, we say that that is a much stronger positive correlation, okay? Because those points match the line in a little bit more detail. So if I wanted to guess, this might be a value, for example, like 0.4 or 0.5. So it's still positive, but it's closer to 0 than it is to 1. Whereas this is probably going to be sort of something like 0.8, 0.9 for a value of R. Okay, so you can kind of guess the correlation coefficient. The closer the value is to 1, so if it's positive, it means, if it's a positive number, it means it's positive correlation. The closer the value is to 1, it means the stronger the correlation. And the closer the value is to 0, it means the weaker correlation. So let's keep going then. Let's have a look at negative correlation examples. So again, the idea here is that this data kind of follows a downward trend. In other words, as one thing increases, the other thing decreases. This might be, for example, something like altitude and temperature, right? You can think as you get higher and higher, sort of say if you're climbing a mountain, you get higher and higher, then the temperature usually drops, okay? Now you can see the one on the left is much weaker correlation because those points, those data values, do not match that line as closely as the one on the right. So we say this is a stronger correlation. So again, if I wanted to guess at R values, I could maybe guess that this one would be something like negative 0.4, okay? And this one might be, for example, negative 0.9, okay? So again, I'm just sort of eyeballing these values. Of course, we're looking at how we can actually calculate the value of R, but I'm just showing you this kind of intuition. The closer the value is to 0, the weaker the correlation, and the closer the value is to either negative 1 or 1, the stronger the correlation becomes. Of course, if it's positive, it means it's a positive correlation. If R is negative, it means it's a negative correlation. So the third option then is when R is equal to 0. So that means that there is 0 correlation. And I've drawn 3 examples here of 0 correlation. Number 1, if the data values are pretty much perfectly in a straight line. Okay, so actually I would say this is quite strong 0 correlation, but we tend not to say strong or weak correlation with 0 correlation. We just say 0 correlation. So because here the value of the gradient of my regression line is 0, I would say there's 0 correlation there. Okay. What this would literally mean, if you think about it, these are 2 variables. I've got my independent and my dependent variable there. What that means is that as my dependent variable changes, in this case, my dependent variable doesn't change at all. So as I change x, y doesn't change at all. In other words, there's not really much correlation happening there. Equally, I could have drawn it as a vertical line as well. This here, okay, so this second graph here is also 0 correlation because you can't really draw a line of best fit through it. Like the regression line isn't that good. So if I try that doesn't really follow the pattern. Equally, if I try that, again, that doesn't really follow the trend of the data. So because it's not really positive or negative correlation, in that case, I'm going to say it's 0 correlation. Now the third one is a bit of an anomaly because it does actually follow, they are actually correlated to each other. Okay, you can see here that there is actually a definite pattern which the data follows. Okay, but because in this course we are talking specifically about linear regression analysis, okay, so we're talking about straight lines, I can't fit a straight line through this data. Okay, that there isn't very good, that there isn't very good. So because I can't fit a straight line, and because the Productmoment correlation coefficient, or the Pearson's correlation coefficient, talks about the correlation with relation to straight lines, I can't talk about the fact that there's any kind of correlation going on there. So I say there's 0 correlation going there. Okay? So just be aware of that. Sometimes you need to actually see the data to see what's happening, and you think, perhaps linear regression analysis isn't the way to go here.